Hey guys, and welcome to this video. I just recently finished consolizing a MVS-1A board and wanted to share with you the high level steps taken in this project, some of the design choices, and just as an inspiration to some of you that might want to do the same. There are a lot of tutorials and even videos about doing the exact same project. All of them are kind of different, and I guess that's where it's interesting to see some of the differences and choose what works for you. This is a custom project, so you can do it to fit your needs. So as nothing I've done here is essentially new, I'll put some of the links and pinouts and videos that I've used as reference in the description in case you haven't seen them yet. Right, so for me this project actually had a purpose, and I wanted this console, if you will, to be used at work. I had that board, that 1A board, and that 161 cartridge in a box, doing nothing, and we've been using a Neo Geo CD at work, which was very good, playing a lot of Metal Slug, some Polestar, a bit of King of Fighters, but the fact that we had to have burn CDs and swap the CDs, and some of the loading times, look, for Metal Slug there was never really a problem, but for the fighting games, one of my workmates really wanted to play some of the later fighting games, and that's where it starts to be a problem. So I thought, look, I'll just consolize this. It'll take me a couple of hours. Yeah, right. It actually took me like 15 or 20 hours. But I wanted it to be simple, clean, safe, but really nothing too fancy. I didn't try to push the boundaries on how it looked. I just wanted to have something where the PCB was not exposed anywhere, that was safe and functional. I should probably explain what there's a bottle of bourbon right there in the middle. I put it there as a tribute because, I did drink some of it while making the project, but I also used some of its packaging to cover some of the open areas on the sides and on the top there. So yeah, here's to Blanton. We started the project with obviously this bare board, and in order to fulfill the requirements, we had to close up all the open areas. Also provide some handy connectivity and some power, some stereo sound, and some RGB. Those were my requirements. The first step I chose to do was provide a solid base and cover all the bare electronics on the underside of the board. So I cut a piece of acrylic, I believe it was 4 millimeters black acrylic. I got it for fairly cheap, about 20 Australian dollars shipped for 5 A4 sheets. And then I found an assortment of M3 screws and spacers and nuts. All of this was bought on eBay, and it provided me the space between the acrylic sheet and the PCB to not sandwich, not press anything, any components on the other side, but not have too big of a gap. So as you can see here, zoomed in, this is what it looks like. I then added 4 feet, the kind of feet that you get at your home improvement store or dollar store. They're meant for furniture. They are thicker than the nuts, and they protect the surface and they prevent the unit from slipping. Next step was to find a way to cover the front of the unit and provide a base for the connectors. I wanted to add the connectors up front because usually the Neo Geo controller cables tend to be short, as most of them come from Japan. Probably never had one from America. I don't know if it's different. So every centimeter count, I guess. So I've seen people mounting them at the front on each side, which is kind of cool, but it's a bit awkward for the controllers themselves, for the cords, just the general flow of the cord. The first thing I tried was to bend a piece of acrylic, for the same material that I used for the underside. I didn't really like the fact that it was too thick, and I moved on to something else. I bent it using a toaster. It actually worked decently well, so I recommend trying that if you've never done that before. Be careful, you know, don't hurt yourself. But yeah, it was surprisingly easy and gave some decent result for a first try. So I found an old case from a UPS that had, you know, something industrial. So it had some really nice steel that I basically cut to dimension. It already had the bend in it, and this is now what it looks like there. At that point, the metal plate was fixed just as a test to the plastic casing using hot glue. I've seen other people do that, and I think some people managed to source some fairly decent hot glue. The hot glues that I've tried, they're just pretty much rubbish. They do not suit that kind of purpose, like holding, you know, a few hundred grams of metal to plastic. So I decided to do something more permanent and removable. It's kind of an oxymoron, but you'll see what I mean. So I used basically pieces of wood. I wanted to create a thickness on which I could drill, and basically holes on the metal plate and drill into something. So there was a gap about 7 millimeters. I found some very thin MDF, the kind that you use for, you know, IKEA furniture backings, you know, that kind of heavy cardboard kind of thing, and I sandwiched them together using wood glue. So it was about 6 mils, and then using a very thin plastic spacer. So as you can see here, there's 3 different points that I used to anchor my metal plate. You can see the spacer there. It worked very well. I had to work out the thickness, the height of the screw, but I can now remove it at will, and it gives me a very solid grip. I'm not afraid of it falling off at any point. The 2 white pieces of cardboard that you can see on the side are actually from the whiskey packaging. They're black on the other side, and they fit nicely. You can really see that it's a cheap piece of cardboard, and they cover the PCB. I'm not too proud of the way I used the hot glue there. I kind of refined the technique, if you will, later on by just smudging thin layers of hot glue rather than those horrible blobs there. Yeah, and I've done the same on the side later that you will see. Now, for the electronic side of things, there were a couple of boards that were required, well, one for audio, one for video. This here is an audio op amp that is required to basically extract stereo sound directly from the sound chip and then amplifying it to a line level, clean stereo sound. This board I've ordered from Oshpark, and it was designed, I believe, by Monkey and MKL. I'm not sure if somebody else actually contributed to the schematics of the op amp or the design of the op amp, and these guys were just responsible for the board design. But anyway, very nice of them to put that on Oshpark, because anybody can just click the button and order some boards directly for them. That's what I did. Just add the components. It's not too hard. It takes about 20 minutes, I guess, to put all the resistors and the transistors. The next board is a tricky one. Bottom line is, if you're not sure what you're doing regarding RGB, it's probably best to use a known working video encoder. Like most of the guys doing CMVS or Consolized MVS use video encoders, NTSC encoders for component, S-video, composite, and these boards were designed for this exact purpose, to take arcade type RGB signal and convert that to a consumer electronic, 75 ohm load video signal. Here what I'm doing is basically putting these components as a buffer in between an arcade type RGB signal and feed that to SCART. And depending on what you're going to use, there might be issues. Now, I'm taking the risk. If you use this on a PVM, you most likely won't have issues, because those are a lot more tolerant in the RGB levels that they accept. But I know that the TV I'm using might have issues down the line. For instance, I wouldn't be comfortable plugging this directly in my OSSC or even a G-SCART. I know these devices have issues when they are not fed, the signals that they expect. Like, they are built to a standard, and the truth of the matter is what I put out there is not built to that same standard. So I'm taking the risk of plugging into the devices that I feel comfortable with. The good news is that I've heard that Volta and other people are actually working on a solution for AES and MVS to output clean RGB. We don't know yet what it's going to be, but I think it could be interesting for this kind of project. So we'll wait and see. In the meantime, I'll explain what this board is for. The 3 lines from the left are actually with the resistors there to attenuate the signal, attenuate the brightness. If you've ever seen a super gun, you see that usually they have pots to attenuate, to put a resistance on each RGB line and basically reach that proper brightness. So I've just measured using pots, and I think my value was 75 ohms. Some MVS boards are 150 ohms, so you should test that yourself. Now the last one is for composite sync, and that resistor and capacitor are to basically drop down composite sync at a TTL level to something that's not gonna blow your equipment, to reduce the voltage. So here's a photo before finishing up the wiring job. I will start from the top left corner. You can see hidden there behind the black cables is the little RGB board. I put it there because it's the closest to the DIN connector, which I used the 8-pin DIN connector for the cable. The reason why I actually chose the standard of Neo Geo CD, because I already have a cable for that, and I also like the idea of having the audio separate for if you want to put to an amplifier or something like that. I don't like the idea of cramming stereo audio on a 8-pin DIN. I know there's enough pins, but it's not that standard. So I wanted to keep with something standard. You could potentially buy a cable from a reputable source, retro gaming cables that GadgetUK or anything like that. So I wanted to keep it standard. Next, in the top middle part, we have the audio op amp that I wrapped in Captain tape. If you see the 3 thick black wires, they all shielded wires. And then as the input of the audio amp, there's a white wire that goes through the hole of the voltage regulator and goes to the underside of the board, which is where we tap our audio signals directly from the chip. Then I used some ribbon wires to solder to the jammer edge and basically wire the 2-player controller, and I found that it was easier to just keep it tidy. The brown and red DuPont connectors there in the middle are for the LED, and I used female connectors because that's where the voltage comes out, and on the LED side I wired some male ones. So let's do a quick overview of the finished product. We have the DIN 8-pin there, which is a standard pin out for Neo Geo, the 2 RCA jacks. I also cut a piece of cardboard, black cardboard there to fill the gap, but I cut it around the dip switches. Now at the front we have the 2 DB15 connectors. I was going to mount them at the forefront of the metal plate, but decide otherwise because now this way I can unscrew them and just remove them for the metal plate if I need to, as they are hardwired on the motherboard. On the other side we have the power switch which lights up and a normal DC barrel jack. In the middle there we got an LED that's just in a blue LED in a LED holder. I did drill the hole too wide by 2 mil, so I had to paint a plastic spacer. It was white and I painted black. You can still kind of notice it, but it's better than having just a hole and nothing that fits inside. So that was the mistake. I just went a little bit too far when drilling it. So one deliberate choice in mounting these connectors was to have them face upwards. I personally hate when consoles or devices in general have cables hanging off the side. I think it's just a poor design choice. I mean, that's just my personal opinion, but we have the PC Engine Turbo Duo, and you got this thick, thin connector hanging off the side, and that just adds like 5 to 10 centimeters of the side of the console, and you can't fit it in tight spaces. So for me, it was important this this console's side footprint, you know, from side to side, was the same as basically the motherboard, and I wanted the connectors facing upwards, except for the controllers, which to me makes sense that they hang off the front, because that's where you are, so you want the cable facing towards you, the player. I also thought that in the end it actually looked cool, because with the connectors all plugged in, kind of looks like a Pro Mixer, you know, with the kind of the XLR plugs hanging off vertically. I don't know, I just prefer it that way. I know some people have done it differently, but that was my choice. Okay, so it's time to plug everything in. We'll start with the power. Right now I'm using my ATX modified bench power supply, and I have a normal DC barrel jack wired with positive center and negative outside. I plug that in that way. It's a bit of a ghetto connector, but it works well. It's got some thick gauge wire. I use that for many different things. To use only one connector like this, you need to do the 5-volt only mod. The audio amplifier on the Neo Geo takes 12 volts, but you can bypass that. I'll post a link to the detailed mod. Next, we'll plug in the video. So I'm using an 8-DIN cable with the standard pinout for Neo Geo. This one here is a mono cable, but in this case on my test bench I'm using some RCA with external speakers. So plugging in the old little PVM, and then your stereo left and right RCAs here to my external speakers. For this particular test, we'll use Fatal Fury. It's the only original MVS card I have. I plan to use this with the 161N1, the yellow card in the background. And there we go, let's turn it on. You can see the power button turns on, as well as the blue LED. Initially I wanted to use a red LED, but I didn't have one, not a 5mm one. So I've ordered some, but I might leave it that way. It's fine. I think blue is more contemporary, you know, of the Neo Geo hardware, but whatever. So all in all, I'm happy with the results. I realize that the finish is far from perfect. You can see defects here and there, but I just wanted something functional that doesn't just look too horrible, and that was safe and nicely closed up, and I guess I achieved that. That's all I wanted, and I'm happy with that. I do realize that, you know, the CMVS game, you know, there's like some heavy hitters out there. You get people that have really pushed the envelope, so I'm not trying to compete. I just did something for me that works, and happy with it. I guess this wraps the video up. Thanks for watching, and I'll catch you soon. Cheers guys.